In Lesson 4, we're going to talk about moles. But before we get to talking about moles, I just want to do a really brief introduction to the periodic table. So the periodic table, you've probably seen it before. There is a copy of one in your textbook, although on the test, this is the version of the periodic table that I will give you. And this particular periodic table, in case you ever want to print one out, or if you lose yours or something like that, it is under course documents if you need to go find another one. The periodic table, the name periodic table, implies a repeating pattern. There's lots of things that repeat periodically. 2 words to know with the periodic table. A period is a row that goes across on the periodic table, and a family or a group is a column on the periodic table. So looking at this periodic table that we have in front of us, there are 1, 2, 3, 4, 5, 6, 7 periods, and you can see that the groups or the columns are labeled 1 through 18 across the top. You'll notice that there are these 2 weird little rows down here. The reason the periodic table is so funny looking is they wanted it to be able to fit on one page. So what they did was they took out this lanthanoid series and this actinoid series and they put them at the bottom. If they hadn't put them here, it would have been really hard to print the periodic table on one page. If you look at the numbering, this number 57 through 70 fits into the 6th row, and numbers 89 through 102 fits into the 7th row. The periodic table contains all of the known elements. Some of these elements are naturally occurring, some of these elements are discovered in a lab. We're always finding new elements, so the periodic table might change every so often and add in some elements. So that's why you'll see all of these funny U's right here. These are elements that they think they've discovered in a lab, but names haven't been given to them yet. So they're sort of strangely marked on the periodic table. When you look at the symbols for the elements, you will notice there are certain elements, something like carbon has just a capital C for its symbol. Something like silicon has a capital S lowercase I for its symbol. So all of the elements have their own symbols, either a capital letter or a capital letter and a lowercase letter. The symbols are going to be important later when we try to write formulas. You do not need to memorize the symbols. You will always have a periodic table in front of you when you go to take your test or to take a quiz. You can have one, so there's no need to really memorize this. Looking at your periodic table, things that we want to know. You probably want to print off a copy of this periodic table, and you probably want to draw things in with me. The first thing that we are going to draw in is the stair-step line. The stair-step line divides the metals on the periodic table from the non-metals. And it's called the stair-step line because when I draw that line in, it looks kind of like a stair-step. Everything that is on the upper right side of the stair-step, these are your non-metals. You are going to have to put up with my really bad handwriting here. Everything that is to the bottom left of that stair-step line, all the way over, these are the metals. There is one exception to this. You'll notice hydrogen up here. Hydrogen is actually a non-metal. Hydrogen is a gas, and it is on the right-hand side of the periodic table. It's kind of the odd one out. Chemists debated about should we put hydrogen over here because it's similar to these other things, or should we put hydrogen over here with the gases? And they decided it made more sense to put it on the left-hand side. So try to remember that hydrogen is still a non-metal. Things that are on the periodic table that touch this stair-step line, those are called metalloids. So boron, aluminum, silicon, germanium, arsenic, antimony, tellurium, polonium, astatine, and whatever other strange, new, wonderful elements they've discovered. As long as it touches the stair-step line, those are considered metalloids. Some things to know. There are some basic properties of metals, nonmetals, and metalloids. A lot of these are going to be things that you already know. Things that are metals are very good conductors of heat and electricity. So that's why you have copper wiring in your house, because copper is a metal, very good conductor of electricity. Metals are considered ductile. Ductile means that I can pull it out and I can create a wire. Metals are also considered malleable. The word malleable you saw in lesson 2, and if something is malleable, it means that I can hammer it into a sheet. Metals tend to be lustrous, so they're kind of shiny. So something like silver has a little bit of luster to it. And in chemical reactions, metals will lose their electrons. That's going to be important later when we talk about bonding. Metals always lose their electrons. Also, metals are all solids. The one exception to that is mercury. At room temperature, mercury is a liquid metal. Thinking about the nonmetals. Most nonmetals share the following properties. Nonmetals tend to be poor conductors of heat and electricity. So these are usually good insulators. Nonmetals, they tend to be gases at room temperature, although there are some liquids, like bromine is a liquid, and there's also some things that make a brittle solid. Something like sulfur tends to be a solid at room temperature. So these are not shiny metals, so therefore nonmetals tend to not have luster. They tend to not be ductile. They're not malleable. Sort of the opposites of what we just talked about with metals. Nonmetals will gain electrons in a chemical reaction. That's going to be pretty important later on. The other thing, if they don't gain electrons, sometimes they will share their electrons, but nonmetals never lose electrons. And lastly, thinking about the metalloids. They're called metalloids because they're sort of the in-between. So they're not really metals, they're not really nonmetals, but they have a little bit in common with both. Metalloids tend to be very dull. They tend to be very brittle, so you're not going to be able to make them into a wire or a sheet. Mostly solids at room temperature. And these things tend to be semiconductors. So that's why you might have heard about silicon chips, like in computers, being good semiconductors. So they do conduct, but only under certain conditions.